Okay, so we're going to talk about PointSense Plant here. And by the way, feel free to ask your questions in the questions pane or the questions panel. We'll definitely get to them towards the end of the session. Now, just a real quick recap, and this is kind of touching back to what Scott was saying right at the end there. If you own plant, building, or heritage, you also do get the functionality of our basic and pro products. But the plant product specifically deals mainly with cataloged piping, structural steel. Also, it has tank analysis, brand new tie and point routines, things like that. So it's basically focused around industrial facilities. So the generic workflow for going from actual reality to your desired deliverables is essentially starting from a point cloud, gathering the data, using our software as sort of the middleman, and then getting those results into your design software to create your actual outputs. So that's your isometrics, your bill of materials, your orthographics, that kind of stuff. Obviously clash detection, things like that. So what is PointSense Plant? Well, you can see the giant ribbon here, and if anyone who's used the software since the beginning, this is probably about 6 times the amount of tools that we started with. But this is an intelligent piping product, and not only piping, but obviously structural as well. It's catalog driven. You have the ability to create catalogs from your specs as well as structural parts, whether it's AISC, CISC, or DIN, even custom parts after that. And as with all of our PointSense products, we work directly on the recap engine. We've actually been working on it since before that when it was PCG, but we will continue to work directly with the Autodesk engine. And every year that's been proving more and more beneficial as it gets more and more powerful. So we're going to start just by talking about the visual interface. You've seen this and the scan navigation stuff in the earlier presentation, but I do want to touch on it because it does play a large role in the plant product. One option you have is VirtuSurv, and this is taken from the binary formats. In our case, the FLS file format is a great way to get this. But you can see on the bottom left of this image here, you have all of your scan positions in your scan map. And that gives you the ability to jump from scan to scan, and you can also see which way you are currently looking, so you know which direction you have to jump to get a better vantage point. As you can see here, you have accuracy better than 1/16 of an inch. Now that does depend on the density of that specific scan, but if you're dealing with 15 to 25 million points per scan, for example, then you should have 1/16 inch or better. Now this is something that we've brought to the table since 2015, and really it was the ability to read the recap file format in a different fashion than we could in 2014, so that's why we have that sort of bridge there. But 2015 and now even better in 2016, we're able to jump into that scan position directly in AutoCAD. So a lot of our users are kind of going this route because it removes having to have a separate external application like VirtuSurv, and you can actually almost mimic VirtuSurv directly in AutoCAD. And just like with VirtuSurv, you have the ability to jump from scan to scan. You can see those spheres there. You can do it in the middle of a command whenever you need, and it does not exit out your command. So a lot of our users are going this route, and it's really nice, in my opinion, because you can verify all your results as they're happening in real time, where you can see the modeling overlay on top of the cloud data. It's a very nice verification of what you just did. The other thing that I really enjoy about this over VirtuSurv is the fact that you can see which points you're physically snapping to, so it's kind of a nice feedback for the user. So before we get into the actual creation of your intelligent plant objects, I do want to touch on the fact that this is all catalog driven. Now, people who have used this software in the past already knew this, but we've added quite a bit of functionality as it pertains to the catalogs. You can see here in the screenshot, we've got our Plant 3D stuff just like we always have. We do have a generic format now, which is actually an API that we've written to encourage other products to be able to read our outputs. And you also can see here that we have the Revit MEP import. This is something that our users have been asking for a while, so we're very excited to have it. And there's also a link there for the plugin download. So if you're using the 16.5 version and you jump to the Revit MEP import, if you don't have the plugin already installed, you can just download it from there and run it. And what you'll be able to do from that point is go into your Revit mechanical template, export out whichever catalogs you wish, and then we'll find those parts for you in PointSense Plant. Now, Walk the Run is probably the part of the software that you'll spend the most amount of time in. And what it is, it's a semi-automated recognition of the parts that you have in your catalog. These are intelligent parts. You can bring in multiple specs if you wish, or you can take a large spec and kind of narrow it down or filter it before you start finding these parts in the point cloud. Now, every year we've been adding additional methods to insert these parts. You'll see this in the video, but we also are finally using saved cylinders in the background, and what you're going to get from this is a much faster detection speed. Before, in the past, we had to look ahead and try to detect these cylinders, and we still do that to a certain degree, but now with the new recap format, we actually have saved cylinders that we can access to enhance this part of the process. So after you have these fittings found in the point cloud and laid out, you then need to do apply constraints. And the reason for that essentially is our software is not perfect, the point clouds aren't perfect, and the fittings in the field aren't perfect. There's always going to be some small amount of error. And your design packages are looking for these fittings and these objects to be coplanar and coaxial. Now, we don't want the user to have to spend all this time going perfectly from weld to weld and making sure everything is perfectly coaxial on the center lines. We can do this for you. We have a number of ways to do it, just reading the data that we have, and then we also have two methods. And I want to explain just briefly the difference between the two methods because they do both have their needs. One is going to be a perfect version of the fittings for your design products. That means all of your 90s are going to be perfectly 90. Center to end lengths won't change, angles won't change, and then you're going to have the times where you need it to be where you need all your center lines to line up, but you need the fittings to actually show their true angles. That's probably most prevalent with cutback and routing elbows, and we actually have a really good way to address that as well. So let's go ahead and jump into this demonstration here, and you'll see we're using the scan navigation mode. And the reason why I recommend scan navigation instead of cropping or clipping is, one, it's much faster. Two, the visual quality of that view is going to be so much more enhanced than having to kind of orbit and zoom to get a perfect angle and then just hope that you don't accidentally snap to a bad point. But really the best part of this, we have customers now that can bring in billions of points in data and you don't lose the visual quality and your AutoCAD doesn't slow down. It's a very nice thing to be able to say that I can bring in all the data and my AutoCAD handles it perfectly. So you're going to see me jumping directly into this scan navigation mode. And again, you can jump from scan to scan as you're doing it, but look at this view here. There's no way that you're going to miss what you're trying to get. So now we're using this enhanced view to use Walk the Run. Previously, you would have either clipped and done this, or you would have done this out of VirtuSurv. But here I'm snapping to the pipe, and we're going to actually go through all of the main features here in Walk the Run. So I'm going to show you a couple of different ways to kind of tackle this line here. But I want you to look closely on that flange there. You can toggle from front of face to back of face to hub, and all of the fittings actually have different insertion planes to toggle from. But here you can see a much faster detection because we are able to see these cylinders ahead of time. There's no Hollywood magic. This is what the software is currently able to do. So from here, we can just zoom over to this side. Now, you saw me insert the flange earlier. I did it from front of face. Here we're going to actually toggle to back of face, but instead of doing it out of the cloud, I do want to show you that you can also use VirtuSurv if that's what you're comfortable doing. So I toggled the back of face as my insertion plane. I'm going to go over here to VirtuSurv and just click any point on the back of face. And you see when I return back to my drawing, it has my flange where it needs to be, and then I can continue going. So it's user preference. We give you a ton of options, but it's up to you to use what you are most comfortable with. And here I use the traditional other pipe option. It works the same as it always has, probably a little bit enhanced because the resulting cylinder will extract further. Then we're actually using a manual insertion using the specified points around a circle. Now this right here, this is your fallback option. This is when our software can't find it. This is when maybe it's not in the data. But the important thing is you have a way to still get your work done. And then all I'm going to do here is just finish the run, and then you'll see very quickly, even taking the time to kind of switch options to make sure you see the whole repertoire of tools that we have, I was still able to get this line done very quickly and very accurately. So after that, I'm just going to turn off the cloud here, and we need to do that apply constraints. It looks good from here, but if you zoom in, you can actually see that fittings are slightly off. So there are the two strategies I talked about earlier. All you need to do is choose any object on the line. We highlight it as green, that means it's connected, and then we do apply constraints. Hardly even noticed a shift, but if you were taking this into Plant 3D, for example, you would have gotten water drops throughout the whole thing. Here you can see no water drops, no disconnects, and everything is good to go. So from there, now that we're in that middle step of that earlier slide I showed in the beginning, now we need to take it to your program, whatever you need to extract your deliverables. Now we've done quite a bit of work with exports this year. This is something that we're going to continue to do, especially with that generic option, and we're trying to entice other companies to kind of latch on to that API. But everyone here is familiar that we have the Plant 3D exports. We've actually included cutback and routing elbow support for Plant 3D. We also have the Revit MEP export, and then this is something we're extremely excited about, and you'll see it in a later portion, but we have the ability to create advanced steel objects. As was the case before, you can create your center lines, you can do your standard 3D solids. We've actually changed the center lines up a little bit, and we'll touch on that very soon, or right now. So this is the difference between what we call simple center lines. Now the simple center lines is what you had before. It's a single center line. You did have nodes placed for start and end points for all your objects, but the workflow to get into products like AutoCAD MEP, CADWorks, AutoPlan, etc., it was not that good. It was very cumbersome. Anytime there was a reduction, the user had to know that, and then he had to either break the line or just kind of take a different route. So what we've done now is we actually still place nodes for all the fittings, but then we place spheres to mark the ends of the reducers, the large ends. We also separate all of your center lines on their own layer, denominated by their nominal size. So you'll have a layer that says nominal size 8-inch, nominal size 6-inch. And for example, if you're using CADWorks, the workflow I use is to use their router line feature, and you just turn on the layer going from smallest to largest. So if you have 10, 8, and 6, for example, you start on the 6, go to the 8, go to the 10, and products like CADWorks, AutoPlan, they're going to automatically place that reducer between those lines for you. So it saves you a lot of time, and then whenever you need to put in your flange valve assemblies, for example, you still have the nodes to snap to, and these programs will automatically break the lines and orient the objects correctly to run along that axis. So this is that line we had before, and in here we're just going to do the Plant 3D export, and all you need to do here is choose your exports. You can see a ton of different options here, and we do the piping and the steel at the same time now. There's the Revit MEP that we've been talking about. We're going to choose these objects, and it's going to start creating your Plant 3D fittings. Now you can keep your qubit objects on your same layer, but here I'm just going to go ahead and highlight them all and delete them, just because we don't need them anymore. But from there we have intelligent Plant 3D objects, and now it's just up to the user what you want to do with it. So you can see here I can continue my piping, go a number of different directions. Also I can generate my deliverable. So here's just a quick ISO. Just choose all the fittings, hit enter. If you have a production level template, obviously you can go that route as well. I'm just doing a quick ISO just to show you that we've successfully gone from no modeling, just point cloud data, and now we're going to something that you would actually turn in as a deliverable. So here are those objects, and you have the bill of materials, fully intelligent, dimensioned, everything like that. Now, this is something that we actually introduced in the last version, but it wasn't what we considered good enough. We've been working on it and talking back and forth to customers on what they would like to see in it. At this point, it is much more intelligent, much more intuitive, and it saves the user a ton of time if you only need tie-in points. If you do not need to model everything, there's no reason why you should have to use walk the run. So this tie-in point routine, it has all kinds of different options to actually specify that tie-in point. You can see here on that top row, you've got your 2 points along a cylindrical axis if you just want to kind of nail a center line to constrain it to. We have multiple points around the flange OD, and we also have 3 points around any circle. Now, in my personal opinion, I think the middle option is probably the best, doing points around the flange OD, especially if you consider the fact that you may not always have a pipe going into the flange. But then in the option below that, you have the ability to toggle from front of face or back of face, and you can also toggle from just a unique offset. So maybe you can't see the flange, but it's this far away from the center to elbow. So there are other options just in case there's no way to actually see the front or back of face of that flange. If you notice below that, it's also grabbing a specific flange from the catalog, and actually it'll pull up multiple options if there are multiple options in your active set. Lastly, one of the improvements that we've added are multiple output options. You can kind of see it in the screenshot on the right-hand side. We do have the ability to label its coordinate, its roll and tilt direction as well, and then we also have the ability to create the solid object, which you can either convert to one of your plant design package objects, or you can just use that to continue your walk the run if you want to go that route. So what I did here is I just decided to fit a tie-in point at the top of 2 of these. Now you're going to see one and then it'll kind of transition into the next. I like to use VirtuSurv just because if you switch to intensity gray, you get a really high level of detail even from that far away. And you can see here just any points around the flange OD. It's really easy to do. It's easy for users to duplicate. Then I can choose either front of face or back of face, and you can change this at the end as well. And all I'm doing is showing you, even from far away, if I can just barely see the back of face, that's enough. So as soon as I change it to tell it I just did back of face, I can choose the option here. Now these 2 flanges fell within a certain tolerance. It's a setting you can change. But then I was able to actually take the flange thickness and apply it to what I just chose out in the cloud. So this first option, you're going to see that it actually has the coordinate and the roll and tilt directions. Then I went ahead and did the same thing on the object on the right. And now all we need to do is convert these to whatever objects you want and then continue your design. So here I'm just using Plant 3D objects. I can get rid of the Qubit objects again because they're no longer needed. And then we're just going to route some piping in between. Now you're about to see why my job is to talk about software and not actually submit projects, because one is I have a very difficult time routing pipe, and 2 is there's no way that anybody would okay the result that you're about to see. But the reason I did it this way is because we're actually going to take this into Navisworks and do a clash detection against it. And that's exactly what I'm talking about. So all the drafting departments in the Houston area, don't hire me. So now what we're going to do here is just get rid of the flanges, because obviously those are going to clash with what we modeled them off of in the point cloud. Now we have that same example in Navisworks. I'm using the clash detective tool here. I have the point cloud selected on one side, the solids selected on the other side, and then we run the test. So immediately you can see the clash. You can also right-click on the model and snap back, directly back into Plant 3D, for example. Here you're going to see me just kind of group these clashes together and then obviously you can create reports and do all of that stuff as well. So it's a really nice start to finish process where everything is integrated. Now, another area that has received quite a bit of enhanced functionality is our structural steel. You saw earlier that I talked about the advanced steel export. We'll definitely get to that. But for anyone who's not familiar with this, this is catalog driven. All your major catalogs are included with the software. It's full pattern recognition, and then we also have ways to adjust the beams after the fact. Now, the arrayed steel fit option, you're going to see this in the video. This is something that we've been missing. It's a very nice feature where you only have to construct a very small grid of the steel, and then you can either copy it, mirror it, array it, whatever you want to do with just standard AutoCAD commands. We'll then take all of those new objects that were created and fit them to the point cloud. So as far as the detection goes, you have a couple of options to enhance or just further verify that detection. You can kind of see it in that bottom left option, or that bottom left screenshot there. So this little green slice on the top of this, or in the middle of the steel, that's your profile slice. So if there's an object that is on top of it, or it's in the way that's actually obstructing that pattern, let's say it's a piece of pipe that's resting on it, you can move that left or right to get a more clear slice of that profile. Now, not only do we try to find what that piece is, we also try to organize the entire catalog in order of what we see as being most likely. So if it's not the top option, there's a very good chance it's going to be the second or the third option. Now, another thing that you're going to see in the video, and you can see it right here in the snapshot, is that we have multiple beam types where you can filter it and say, hey, this is an I-beam, this is a channel, this is an angle. From certain angles, everything's going to look similar, especially if it's further off in the distance. Maybe there's not enough data on it. Maybe just the vantage point's bad. Whatever the case is, you can physically tell the software what it is. Another place where this really comes in handy is if you have back-to-back channels versus an I-beam or a wide flange, or maybe you have back-to-back angles instead of a structural T. It's very difficult for any software product to know the difference between those, so you have the ability to override it. This is just our way of saying the world will not be taken over by robots. Now, the last thing you can do here, and you'll see this more in the video, you can't really see it in the screenshot, but you can hold down your left mouse button and actually erase noise or disruptive data from the preview. So if you've got, like I said before, if you've got a piece of pipe kind of sitting on top of the steel, you can actually erase the pipe out of the calculation and then hit the recalculate button, and it'll find a much better pattern for you. And last but not least, we do have the brand new advanced steel export. For anyone who was using the last version, I'm sure you're familiar with the SDNF export. That's a global standard that goes into numerous major structural design packages, but we also have advanced steel just as a direct export. Now, similar to the piping, we do need to have an apply constraints, and it's actually for the same reasons. The software is not going to be perfect. The point cloud is not going to be perfect, and the steel in the field will not be perfect, especially longer pieces that have sagged in the middle or something like that. So we need to have a way to construct it where your structural design package will accept the results. Now, we have a way to specify whether it's your center point that you want to match up, whether it's your top or bottom. You can actually toggle between, I guess, constraint points. And if you need to, you can actually say, okay, these two pieces, I want to go ahead and match up their top left corner with this piece's, top right corner. But, by and large, the overall workflow is to go ahead and find the piece in the field using the stuff you saw on the previous slide. And then we're going to find everything that connects within a specific tolerance. So let me go ahead and start this demonstration here. You're going to see all the stuff that I just talked about, but then you're also going to see it exported into a different design package. So I'm doing a detection on this vertical piece, and again, it's going through the entire cloud and organizing it in order. You have that green slice that lets you change it, but I had a good profile there, so I'll just continue. Then I can extend the beam here or do it later. I always like to do it here in the very beginning and then extend everything up to that later on. But then we're going to go ahead and detect these horizontal pieces. So if I wanted to, I could have filtered the beam shape. Now I can move my slice, and then here's where I'm actually erasing data that would get in the way of the detection. So now I'll just extend this out here. And from this point on, we already know what the piece is. We also keep track of your previous insert, so you can toggle back and forth. But the user's job at this point is just to click on the steel where it, where it occurs in other places. So you can see here, didn't have to worry about connecting them up. We'll do that later, all at once. But now I can take all these parts and copy or array or mirror and just move them throughout the cloud and detect them, all at one time. So here I'll take these pieces. I just went here and did copy selection, and then I choose a base point, and then choose the similar base point at each iteration. Now, when you see that sphere, that means that our software is waiting to fit all of that to the cloud. So we're going to go ahead and go on the other side and do the same thing here. But hopefully you can see how much of a huge time saver this is, because as soon as we're done copying these to certain locations, we then just hit a button and it will find each one of those where it is in the point cloud and readjust all those objects. And it doesn't have to just be one direction. You can do a full grid horizontally, vertically, and diagonally. So here I'll just turn scan navigation off just so you can see a little bit better. Go from just a normal view. So you can see here we've got a ton of steel that we're going to fit to the cloud. And then as soon as you start the process, it'll ask you to confirm. It'll tell you, hey, we've got 28 pieces. And then really it's just kind of a waiting game. So you're going to see the progress bar on the bottom right. I went ahead and sped this up a little bit. It took 48 seconds for anyone who's counting. There's no way you can prove otherwise. So you can see all the pieces are fit. Now the only thing that we have left to do here is extend them or make them line up as far as their center lines go, because they're still off in certain regards. This is where our Apply Constraints tool comes in. It has a much better interface, lets you specify an angle and a distance tolerance. Then you can see all the pieces that do fall within that tolerance line up to each other. Now there is also separate ways to see how much things were adjusted to make them line up, so anyone who needs sort of an analysis, you have that option as well. So we're going back to the export. You can see the advanced steel, you can see the SDNF, and in this case we're just going to choose these objects, and I chose to bring these into Revit in a structural template using Autodesk's advanced steel utility. So that's the SDNF file. Here's my Revit. You can see the advanced steel extension right there. We're going to do the import. I'll choose the SDNF format, and all we need to do is choose the file. And the important thing to remember here is these objects are coming in with their correct geometry, but they're also coming in with their correct intelligence. So as I choose this object here, you're going to see in the properties over here, it's a W14 by 82. That's an intelligent object. So it's not just a solid. You can do anything you need to with your structural design packages. And this is the last sort of major feature of our plane software. I also wanted to talk about planar analysis as well, but this tool and the planar analysis actually got covered in some of the other presentations or in the previous presentation. But that tool, as it pertains to tanks, it's very nice because you can unwrap the point cloud like you saw earlier. You can also create very detailed reports in Excel, and then you can create that polyline grid that we saw in Christina's presentation. Now, in that Excel report, you can do volumes or volumes at specific height intervals, and you can also do around the circumference. So when you bring it into Excel, a lot of our customers are doing, at least in my experience, they're doing very short vertical increments and maybe a little bit more lenient horizontal increments. But you can get a deviation analysis on the surface, or a deformation analysis on the surface. You can also get volumetrics at every single height, and it'll give you the specific volume of just that 1/8 inch, for example, and it'll also give you a running total. And for any kind of deadwood or any kind of objects inside the tank, whether it's structural or piping, whatever would affect that volume count, we have the ability to remove that as well. This is just a very quick example of some of the outputs. The color deformation map on the bottom right there, that's actually the surface that's been unwrapped. I always tell people it's like taking a rolled up poster and just unwrapping it on the wall. But you can read it from left to right and see if there is any noticeable deviation on that surface. So if the surface has been deformed over time or from an accident or something like that, you can see it very quickly. This is something that we added in the 15 release, but I did want to go ahead and put it there in case anyone is interested in it. But we do have the frustroconical analysis as well. It works exactly the same way, just has a different shape that it can fit, to the equipment. I know I kind of went through that stuff pretty quickly there, but I definitely appreciate everybody's time, and I'm not sure how many questions we have, but I definitely would like to get to those.
Yeah, so got quite a few questions here. I started answering some of them privately, but be good for the group to hear it. So the first one was, while you were showing the scan navigation, someone mentioned that there didn't seem to be a lot of lag. So is that the case with AutoCAD now? There's not a lot of lag while you're, what are the recommended PC specs? What were you working with in this case?
So in my case, my computer is about 2, maybe 3 years old, 16 gigs of memory on this one. I think I have 2 1 gig video cards and a Core i7 processor. I want to say it's 3200. But to be honest, as long as you have the recommended specs for, what Autodesk recommends for a recap, then you should be fine. There's 2 main reasons why you don't lag on AutoCAD in the 2016 release, especially. In 2015 with the recap engine, you had a lot of slowdown when you tried to clip or slice the point cloud. It was a limitation of that version of the recap engine. In 2016, it is a night and day difference. I'm sure anyone here who's moved up to 2016 already knows that. The other thing, and more importantly, is the scan navigation. When you have, let's say you have 150 scans. Let's say you've got, 2 billion points. You've got them all on your screen. The visual quality is down a little bit. The speed's down a little bit. When you jump into that scan navigation mode, you are removing any other data that is not line of sight to the scanner from that position. So the way that AutoCAD works with the recap engine is the less data that you have visually loaded, the better that the performance is. So you can jump from scan to scan, keep your visual quality at 100%, and also you do not have the slowdown associated with having billions of points graphically loaded. Now, the other thing that's improved in the 2016 version is when you have the points unloaded visually, when you're in ScanNav, we're still able to read those in the background to do pattern recognition and to do any kind of calculations that we need for our software. So it's really a great release for the recap engine.
Right. Yeah, just to reiterate that, just for everyone, everyone's knowledge, what John's saying is when you run a piping command, when you run a structural extraction command, any of the extraction routines that you saw, even though the data is isolated, we're still able to use the isolated data, which was not the case in 2015. So if you have the option to move to 2016, do it, because the experience is much better. So next question is, do the catalogs include different valve sizes and types? For example, showing hand wheels and things like that.
We definitely have different sizes and valve types. We actually have, I want to say, 15,000 valves in our current catalogs. As far as the hand wheel goes, we don't have a way to adjust that. They actually do have a hand wheel, but it's a specific size. And hand wheel sizes change so frequently. We just decided, hey, let's let everybody do that part of it in their design package. we always run the line or walk the line between being a design package and being a pattern recognition package. And as you kind of saw in the very beginning, we want to be that middleman. We want to be that go-between to get you from cloud data to your design package. So we never want to duplicate any kind of development that's being done in that design package because we're trying to get you there anyway.
Right. Let's see. So this is a fairly loaded question here, but I think which is why I didn't type an entire paragraph to the gentleman. But what is the best way to ensure the modeled pipe run is in line with the point cloud after the constraints have been applied?
There's two ways on that. One is you can use that cylindrical analysis or cylinder analysis on the pipes, but we also have an option in the apply constraints to place objects on these hidden layers that will show you how much these objects have moved. So especially if you're using apply constraints 2, where you're taking real world examples and trying to make them conform to design plant design packages, those are going to have the greatest amount of deviation from the point cloud. I say greatest, it's really not that much at all, but it's more than apply constraints 1. But if you go on these layers and you check that option, you'll actually see these polylines that will signify where the object started from and where that object moved to.
Right, and maybe, because you mentioned it briefly, but maybe touch on how we are supporting, cutbacks and those types of options now, as opposed to the previous versions of PointSense Plant.
Yes.
Can you go in a little more detail on that? Like how are we supporting, and how does that compare to the previous versions?
I'm sorry, the last part of the question cut out, Scott.
Oh, okay. I was wondering if you can go in a little bit more detail about how we're supporting cutbacks as opposed to how we did it before.
Yes, so if the elbow is within a certain tolerance, and this actually also goes in conjunction with Plant 3D's recent improvements on allowing that tolerance or making the tolerance more helpful, I guess, or easy. But if it's within that tolerance, you can have an elbow that's greater than 90 or less than 90. And you saw it earlier when I showed that screenshot of having the center lines, denominated by nominal size and having the reducers kind of labeled by the spheres. But that's also very good for being able to create routing elbows and cutbacks. And so what you would do with that is instead of using apply constraints 2, you would use apply constraints 1. And the apply constraints 1 is built to give you model results that are almost exactly what you see in the cloud. It's the most accurate to the cloud option available. So after you do apply constraints 1, you would do that complex centerline option where it gives you those new center lines, and then you would use Plant 3D's line to pipe option. Now the only thing you have to remember is you have to have the option enabled to allow cutbacks. And I think it's called toggle cutbacks. The other thing I've seen a few of our customers do is use the option next to that, which is the toggle pipe bends. If you do it that way, you can actually use the simple centerline creator where it's just one solid centerline throughout the entire run, but it will turn it all into a pipe bend. And that way, if you highlighted the Plant 3D elbow, or what looked like the elbow, it would actually show up as a pipe. But either way is fine for the user, and I think we have some slides and how-to videos on how to do that from our recent presentation.
Yeah, we do actually, and I believe in the what's new that I mentioned earlier at the very beginning of this session, it also shows those functions in more detail. Question, well, first a comment here, someone trying to boost your confidence on your pipe run that you showed for tie-in point extraction. Your pipe run is great for shipbuilding, John, by the way. So
it is great for shipbuilding. And then we also have a new tool where you can fit multiple slices. You can fit a polygon to multiple slices, and that's actually really good for the outside shape for the ships as well.
Right. Yeah, the auto polygon fit from multiple cross sections is pretty cool. Let's see here. Is the profile slice always perpendicular to the surface of the steel selected on the point cloud, or is it coordinate driven? So most of you saw that when that preview of the steel piece comes up, it's always a perpendicular view slice. And so the question is it always like that?
It's always, it depends on the points that you choose, and then it automatically goes perpendicular to those points. So that's why we always tell people go ahead and click 2 points on the same planar surface on the structural, and then we actually make a profile slice perpendicular to that. And the goal of our software products, amongst all of the PointSense products, is that we don't really want you to have to mess with your UCS much. You know, obviously knowing how to use the UCS and being comfortable with it is a huge advantage when dealing with, you know, 3D modeling inside of AutoCAD. But we want to go ahead and automate it wherever possible, because it's just one less step for the user and one less way for the software to not give you the result you want. But, you know, long story short, yeah, it just completely depends on the 2 points you pick to detect that steel.
Yep.
Oh, and one other thing, after that, after you know what the steel is, after you've detected it, then you can pick any 2 points on the steel and it'll fit it for you. So those 2 points can be on any planes.
Right. The initial detection, just click 2 points on the same face. That's the rule. Afterward, once you have the same repeating size, you can click 2 points anywhere on other structures that match that same size. But to set up the initial extraction and detection, same face. Does this work with steel shapes that are curved, like you would find in a steel ship hull?
The generic answer is no, that it does not work with curved shapes because the structural design packages don't accept that. But there is a really good way to do that, and I've done it quite a few times, especially with like conveyor systems or rails that, I mean, they almost look like roller coasters, to be honest. But the way you can do it, we have ways of capturing that path, you know, how it curves, or, you know, what path it curves along. And then what I do is I walk users through detecting one side or the other. And so you're detecting what the shape is, and then you're actually placing it. From that point, you can use AutoCAD's Copy Faces tool to take whatever you detected and put just the face of it right on the edge of that path. And then you just extrude along a path, and it gives you that object. I have a video on that, so if you can go ahead and email us, I'll send you that video, and hopefully that'll get you where you need to go.
Okay. So a question here, do you have any options for holding or storing the data, perhaps on an external server we can run off of, you know, so that multiple people can use the same cloud, etc. Really, that's more on the Autodesk engine architecture. And, you know, because we're basically borrowing their engine for function, that would probably be more of a question for the Autodesk reality capture team, if that's something that they're going to allow. For us, for now, the way that the recap engine works, we still recommend, and correct me if I'm wrong, John, but we still recommend using the data locally. It just runs more efficiently than through the server.
Without a doubt, you want to use it locally. And for anyone who needs to have that stuff stored on the network, actually that would be everyone once the project's finished, just make sure that when you load the point cloud locally, that you use the relative option. That way, when you copy the drawing back up to the server, if you have that cloud data sitting where it originally was on that server, it'll still show up in the drawing when you open it again. That's just because it's on a relative path versus an absolute path.
Right. Short question for converting CADWorks specs to the PointSense catalog.
So this is kind of a it's a little, I guess, fishy now, or not fishy, but it's just a little touchy, I guess. CADWorks has recently changed their spec format. Now, prior to that, there was a way to do it with the spec editor, and there were also some companies that had utilities that would physically do it. I know ECAD had one for sure. As it's been since they've changed their spec format, I don't even think you can take old CADWorks specs and convert them over. So to be honest, I'm not sure how to deal with the new ones, but if you need help dealing with the ones that were, I think they're classifying them as 2012 specs, go ahead and contact me directly, and I'll show you how we do it.
Right. There are methods to get some of the older specs in, and also if it goes beyond something that we know, our partners locally over here at ECAD, they have a lot of knowledge on that subject, having so many CADWorks and Plant 3D clients. So if you're not familiar with ECAD, check them out. They're plant design experts in the Autodesk world as well. Are there any YouTube videos on using MEP with PointSense Plant? I believe that's something that's in the works now.
Yes, and actually I probably should have put a video in here about that. I didn't realize that, I only had about 35 minutes of material, but yes, we actually have a way to go into Revit and use a utility that exports out whichever catalogs you want. And what's going to happen when you go into PointSense Plant is you can then take that and start using Walk the Run on that specific catalog. It's a very simple process, only needs to be done once, and then we'll find it from that point on. And then if you notice during the export section, there was a Revit MEP option. That Revit MEP option creates a text file with all the necessary information for you to go into Revit and bring them in as intelligent Revit piping.
Hey John, do you mind backing up to the slide or to the video, the structural video where you imported, because it did show in the Revit ribbon. I just want everyone to be able to see it and to realize where it is. So this is in 16.5. I would kind of scoot to the end of the video here. You have this utility built into your install folder. And like John mentioned, if you're not sure where it is, you can also go up in PointSense Plant and click on the export button, and you'll see if you select Revit MEP, there's an option for installing that utility. It doesn't install automatically. It's only for people that want it. You can see that he's showing it in the slide there. When you click the export option in the ribbon, Revit MEP, you see the Revit plugin download link there. And that's going to help you install that plugin. Now if you jump into the video and show where the structural, where you're importing the structural to Revit. Sorry, I'm making you fly around the PowerPoint here.
Almost there.
Okay. So if you look up here at the top of the ribbon, you see add-ins. It's highlighted now. Then you see PointSense, and next to that you see PointSense Plant. So when you install that Revit MEP utility, you get this extra ribbon inside of your Revit, and all it's going to have on that ribbon right now for PointSense Plant, it's going to have an option for extracting your MEP specs out of Revit, and then there's an option that when you're finished with your piping in PointSense Plant, there's an option to import the pipes back into Revit, and that way they come in with intelligence. So I just wanted to harp on that a little bit more. For those of you needing intelligent MEP piping, you can do it if you have PointSense Plant. Just the same as you can do the structural. It's there, and the utility is very simple to install. Okay, so let's see what's next. What about AutoPlant specs? And I believe that's a little bit easier.
Yeah, that's just using the spec editor tool. It will work with CADWorks or AutoPlant specs, or the older CADWorks specs.
Referring to the Plant 3D spec editor tool?
Yes.
Right, and sometimes we can help assist with that too, but if you have access to the Plant 3D spec editor, you should be able to import your AutoPlant specs. Once you do that, PointSense Plant provides a utility inside of our catalog options for importing Plant 3D specs directly into our format. So as soon as you get them into Plant 3D format, then you know that you can get them into our format. Let's see, is there a way to create a qubit surface from the point cloud over a curved surface?
I would actually use the tool that I was talking about earlier. It's a multi-slice tool that, or it's a polygon fit around multi-slices. That's a great way to do it. We also have the planar analysis tool, which is really good for, you can fit a surface to a wall, you can fit a surface to the ground. Now, if you're doing something like you want to model a statue with all of its intricacies, we're probably not the software for that. But if you need to model tunnels, roadways, bridges, things like that, either planar analysis or fit polygon to multiple slices. And we do have videos on both of those, so we'll make sure to have those available either on our YouTube channel or wherever else marketing puts it.
Right, yeah, and there's actually a good video up on that YouTube channel showing how we use the planar analysis tool to extract only the ground points, then convert those ground points to a Civil 3D digital terrain model. So you can do that as well, and you could extract ground points, but like John said, you can use that same tool on wall faces and other objects as well. Okay, let's see. Is this video recorded? If yes, where can I get a recording? Yeah, so if, obviously you all have registered for this, when the recordings we're going to basically chop these up because we're doing all the PointSense for AutoCAD sessions at one time today. When they're all chopped up into their individual portions, we'll be distributing them, and you'll be able to download them. We'll also post them on the YouTube channel as well, so you can just stream them. Okay, another question. What is the best way to draw conduit that bends in different ways?
The way that a lot of our customers are doing it is using a VirtuSurv macro. This is also there's also another macro that's really good for getting a primitive model of equipment or cones, barrels, drums, that kind of stuff. But yeah, there's a macro in VirtuSurv, comes free with the software. We also train on it. We have instructional videos on this specific macro. But yeah, it's great for conduit. It's great for electrical lines, hydraulic lines, hoses. I actually did a coiled up garden hose a little while back. It is going to give you a 3D solid as your result, but that's something that really isn't even in catalogs to begin with. Like you said, they can bend in different ways, so there's no real pattern for us to kind of latch onto there. But you still get a 3D solid with minimal effort, and you save a ton of time. So we actually have that video available for that macro and other macros as well. So if you just go ahead and email us, I'll make sure you get that material.
All right, one of the challenges with conduit that we find is, especially when it's very, very small diameter, the scanner, if it's far away or you only have one angle on it, it doesn't pick up the entire, it doesn't look like a cylinder. If you were to slice it and look at it from a top view or front-facing view, it doesn't even resemble, in some cases, a circle. And so when you're asking a software to pattern recognize cylindrical shapes, it's difficult when it doesn't look like a cylinder. So there are some cases where you can use some of our traditional extraction tools, but that's what John's talking about with this macro that's been developed internally. It helps extract those items that algorithm would have trouble extracting on its own. Okay, let's see. I believe that's all the questions. We've got about 5-minute padding time here. Is there any more questions on PointSense Plant? All righty. Wait just a sec. I'm going to go ahead and take the screen back here. And since we have a couple of minutes, I just wanted to share something quickly with the group here that kind of relates to PointSense Plant. So let me skip ahead here. I wanted to mention that we have additional upcoming webinars, and I'll mention this at the end of the next session as well. But we do have the VirtuSurv webinar if you want to learn more about VirtuSurv in general. That's coming up tomorrow. We have the TachyCAD webinar, which is one of our traditional products for surveying with the total station. And then we have the PointSense for Revit, which is probably our new popular kid at the group here. So PointSense for Revit's coming up on October 20th, all new functionality, pretty cool stuff. If you want to register for those, go ahead and go to FARO3dsoftware.com, click on the banner at the top of the page. You'll find more information on the link that that takes you to on finding where all the webinar dates are, stuff like that. So be sure to sign up for those if you're interested. The other thing I want to mention related to plant design especially is we are still seeking more feedback. We have some stories in mind, but we're seeking more feedback for Autodesk University. We'll be on site as we usually are. But John is going to be leading a class with Isabel on the realities of today's plant design project. So it's a lecture. So if you have some cool stories where you've used PointSense Plant, or maybe you want to try out some of these new features like tie-in points, anything like that, send them to us, and we'll help make you look good in front of the Autodesk community, and we'd love it. So let us know if you've got a cool idea in mind, or if you want to test drive anything new here that you see. And then I'm going to be moderating a Scan to Fab, which is more building and structural related, so talking about everything from structural steel work, analysis, deflection, extraction, and building face, facade drawings, and elevation drawings. All that. It's going to be a round table, and I'm going to be kind of co-hosting that with Udo Hideki from Advanced Steel team. He's Autodesk product manager, and we might have some more co-speakers as well helping us out. So I just want to mention those classes. Give us your stories if you have them. We'll make you look good, and we'd love to see how you're using the products.